never done it before.
Okay, so one technique that we have not talked about yet is substitution. With substitution, maybe we need to throw a little disclaimer out. So there was one homework problem that I did go ahead and give you last night, and the directions said to use substitution, and several of you asked me about it, and I said, well, you don't really need it here. You could still just factor it like a trinomial. A problem like this, can anyone, if I don't teach you substitution, can anyone tell me how you could solve this problem, or how you could factor it? What would you have to do with that? If you have an x plus 2 squared, we would look for a GCF. We have 3 terms. Only 2 of them have it.
Distribute.
Okay, could we multiply this whole thing out? Could you do x plus 2 squared, FOIL that out, distribute, add your like terms, and factor at the end? Absolutely. So if I gave you this problem on the test, I'm not going to specify how. I'm just going to say factor. So if substitution works for you, that's great, do it. If it doesn't, you could multiply it all out. That being said, if there's another way of doing it, why am I even bothering to teach substitution, right? That's everybody's first question. Because there are scenarios where we need substitution, where we can't just multiply everything out. If it were like a 1/2 power, can you do x plus 2 to the 1/2 power? No. Now, we're not really going to encounter those kinds of problems until later on in the semester. So I'm going to show it to you now, but just know we'll cycle back to it. So right now, I'm kind of showing it to you, give you a taste, and the problems I'm going to give you, you probably won't have to necessarily do it this way. But later on, we will have problems where we have to use this method, and I'll show it to you again then, all right? Did you do any substitution in Algebra 2? Maybe sound familiar? With solving some of them?
Linear equations, I think.
Okay. So if I'm looking at this, it's kind of like a quadratic, because we have something squared, we have that same thing to the first, and we have a constant, right? You're used to something like 9x squared plus 3x minus 2. You guys paying attention to me over there? So let's try substitution. When we do this, I'm going to pick some letter other than x, because I already have an x. I usually just do u's, but it doesn't matter. And I'm going to let u equal this x plus 2. All right, so then if I plug that in, x plus 2, what am I replacing that with?
U.
So this is 9u squared, plus 3 times x plus 2, so 3u minus 2. Does this look like a problem you could solve?
Yeah.
Yeah, we can bring our 9 down, so we get u squared plus 3u minus 18. What multiplies to negative 18 and adds to positive 3?
Positive 6, negative 3.
Okay, now what?
Divided by 9.
Divided by 9. So 6 over 9, that reduces to 2/3. So you bring the 3 back in front, so that's 3u plus 2. 3 over 9 reduces to 1/3, so you bring the 3 back in front, so that's 3u minus 1.
Do you have to re-put it in x plus 2?
Yes. Is everybody okay to this point? My directions were to factor this. Did the original problem have u's? No. So I have to get rid of those u's. So I'm going to replace the u with x plus 2. So that gives me 3 times x plus 2 plus 2. And 3 times x plus 2 minus 1.
Do we have to use brackets, or can we just
You
use
can do
parentheses? Yeah.
double parentheses, that's fine. Can I clean this up at all?
Yeah.
Yeah. If we distribute, this gives us 3x plus 6 plus 2. Can I go ahead and write plus 8?
Yeah.
If I skip a step in your loss, tell me. This would give me 3x plus 6 minus 1 is plus 5. Did that save me time? Probably not really in this problem. I'll be honest, but there are situations where we have to have this technique. So I'm trying to show it to you a couple times throughout the semester instead of just one day saying, okay, all of a sudden now you have to do it this way. Trying to kind of give you a feel for how it works. If you really didn't like this at all, we already said, what could you have done at the beginning? Yeah, you could have multiplied this whole thing out. We know that when we have an x plus 2 squared, you have to FOIL that, so you would have your x squared plus 4x plus 4. Distribute your 3. We would get a 9x squared plus 36x plus 36 plus 3x plus 4, and we just keep combining like terms and then do your slip and slide with that. So in this one, yeah, it might be faster to multiply it out, but I'm just trying to start showing you some of these methods now. Let's try one more substitution one together, and then we'll look at that homework. Let's do this one. So if I wanted to do this with substitution, what would I do first? What is my u going to be?
2a minus 1.
This one to be the 2a minus 1. So if I make that replacement, what is my problem?
16u squared minus 40u plus 21.
So now I have to bring down my 16. What's 16 times 25? Grab a calculator if you need it. Hmm?
400.
What multiplies to positive 400 and adds to negative 40? Negative 20 and negative 20. Now what do we do?
Replace, or we put it in the bottom.
Do I have to write this twice, or could I just do it once to the square? Okay. So 20 over 16 reduces to 5 over 4. So 4u minus 5 squared.
And then replug the 2a minus 1.
Replace my u. So if we multiply that out, we get 8a minus 4 minus 5 is minus 9. All right, I am going to finish this last part, guys. You need your notes. The last thing that I want to discuss with factoring is sum and difference of cubes. So we've done difference of squares. Can you factor a sum of squares? No.
No.
With cubes, we can factor both of them. And there is actually a formula. So if you have x cubed plus a cubed, that factors into, maybe I should I? I'm not going to use x because most of our problems use x. I don't want you to get confused between the formula and the problem. How about I do a cubed plus b cubed?
That's what we learned last.
Okay, I was trying to remember which way she did it. So that would be a plus b. A squared
Square root minus AB plus B squared.
Good job, Kate.
No, no.
Alright.
So you should.
Difference of cubes. So A cubed minus B cubed. That factors into A minus B. A squared plus AB plus B squared. So make sure you have these formulas written down. I will not make you memorize these. So if you need it, I will give it to you. You just have to know how to use it. Alright? So let's try a couple. Let's say, alright, x cubed minus 27. So 27 is the same thing as 3 cubed. So in my formula, it's subtraction, so we're doing the difference. My A is just x, and my B is 3. So it factors into A minus B, so x minus 3. A squared, so x squared, plus AB plus B squared, and that is factor. I always have people that try to factor this trinomial at the end, like doing slip and slide. As long as you pull out your GCF at the beginning, this trinomial is never going to factor any further. Okay, so you don't have to spend your time trying to do that. Just make sure you check for GCF before you start your problem. And then this will be our final answer.
Will we not do anything with the negative?
That just tells you which formula to use.
Okay. I didn't know if it like.
Dude, I lost 6 pounds while I was sick.
All right, let's do a hard one.
Man, that's wrong.
So, 64 x cubed y cubed plus 125. So let's take a second before we actually do it and see if we can figure out what A and B are. So we know we need something to the third plus something to the third in order to be able to do this problem, right? Do I have a GCF, first of all? No. Okay, so 64. What to the third is 64?
4x.
And then we would have an x and a y. What to the third is 125? Okay. So that means in my formula, my A is 4xy, my B is 5. Which formula am I using? Sum of cubes. So that goes to A plus B. So 4xy plus 5 times A squared. Okay, 4xy. If I square that,
16x squared y squared.
yes, you have to square every piece of it. Minus AB, watch it. So A times B
20xy.
plus B squared is 25. And that
That's
would
all
be
she wrote. No, don't call it.
What if, one more.
A.
Yeah.
Oh, that's.
You have to be careful. These are both perfect cubes to start with, but you have a greatest common factor. So we need to pull out that 8 first. Okay. So my 8 is just going to trail along. What is the A in this problem?
2x.
Right, it's saying what cube gives us 8x cubed, so that's 2x. What's my B?
Y.
So the 8 just comes down. Which formula am I using?
Difference.
Difference. So that goes to A minus B. So 2x minus y. A squared
4x
plus AB
2x
plus B squared.
y squared.
Any issues? So that's really all I have for you today. I can do more problems if you guys want extra review on anything that we've done. What I have posted is, it's titled R.3 Day 3. It's another handout. It has problems like everything that we've done. So there's some that are just GCF. There's some that are trinomials. There's difference of squares, sum and difference of cubes, a little bit